Hello everyone. Today we are going to learn about the sets. Under the unit sets, we will be doing definition of sets, types of sets, sets representations and some verbal problems related on sets. Let's begin the class with the definition of sets. A well-defined collection of objects or things is called a sets. A set is represented by a capital letter A, B, C, D, X, Y, Z, and its members are represented by small letters and it is enclosed by a curly brackets. Let's see few examples on sets. Set A. A is the set of natural numbers. First of all, we should be able to familiar what is well defined and what is not well defined. So here in set A, we have set of natural numbers. So everybody knows natural number starts from 1. So it is well defined. If I'll write down a set B, the set of smart boys, which is not well defined. The same person can be smart in front of a single person's eyes, whereas other may not find out that person as a smart. So that's why it is not well defined. So to be sets, it should be well defined. And there is a symbol belongs to. This means the members lies in that set. Suppose, say in set A, we have set of natural numbers where 1 belong to the set A. It means 1 is the member of the set A, and the symbol does not belongs to means the member is not in that particular set. For example, 0. 0 does not belongs to set A because the natural number starts from 1. So it is clear from here that a well-defined collection of objects or things is called a set, and to be set, it should be well-defined. We can write down sets in two different forms. One is tabular form, and the another one is set builder form. So tabular form means if we list out the member of the set A like A, E, I, O, U, then it is called a tabular or roster form. And if in place of this, if we write down the set of vowel letters, then it is called set builder form. So in sets, every time it is not possible to write down all the members in listed form. In that case, we use set builder form. There are different types of sets, such as empty sets, A set in which there is no member is called an empty set. For example, number of boys in girls' school. So in girls' school, there is no boys. So that means the set is empty set, and it is represented by only the curly bracket or the symbol phi. Now another one is finite set and infinite set. A set having finite number of member is called a finite set, and a set having infinite number of member is called an infinite set. Finite set means, for example, the odd numbers between 10 to 50. Here we can count the number of members of this set, so this set is called a finite set. Whereas infinite set, the example of infinite set is the collection of odd numbers which we cannot count. There are infinite odd numbers in our number system. Let's discuss about the relation between sets. Relation between sets. Number first, subset. A set A is said to be a subset of set A. A set A is said to be a subset of set B if every element of set A lies in set B. For example, A equals to X such that X is a letters of English alphabet. And a set B where X says that X is a vowel letters. Let's discuss about the relation of sets. A set A is said to be a subset of set B if every element of A is also an element of B. This relation is denoted by A is subset of B. This is read as A is contained in B or B is contained in A. Here B is also as a superset of A and we write as B is contained in A. Symbolically, A contained in B is defined as X belongs to A implies X belongs to B. X belongs to A implies X belongs to B. If every element of A is also an element of B, but there is at least one member in B which is not a member of A, is known as the proper subset of B. This relation is denoted by A is proper subset of B. Here, the members of B should be at least more than one. Here, members of set in set B, there should be at least one member more than in set A. This relation is denoted by A is subset of B. And for example, in set A equals X such that X is a letter in English alphabet. A letter in English alphabets. And we have set B in which X says that X is a vowel letters. If every element of A is also an element of set B, but there is at least one element of B which is not an element of A, is known as the proper subset of B. Here in set A we have X says that X is a letter in English alphabet, and in set B we have X is vowel letters. All the members of B are the members of set A, therefore B is the subset of A. It is called B is proper subset of set A. Now equal sets. Equal sets. Two sets are said to be equal sets if each and every member of the set A, both the sets are same. For example, set A equals 1, 2, 3, and in set B we have 3, 2, 1. 2B equals, first of all, number of members of both the sets should be same. Not only the number of members but also all the members must be same. Intersecting sets. Intersecting sets. Two sets are said to be an intersecting sets if at least one member is common in between two sets. For example, in set A we have 1, 3, 5, 7, and in set B we have 3, 5, 7, 9. There should be at least one member common in two sets to be an intersecting set. Next, disjoint sets. Two sets are said to be disjoint sets if none of the members are common in between two sets. For example, in set A we have 1, 3, 5, 7, and in set B we have 2, 4, 6, 8. Set A is the group of odd numbers, and set B we have a group of even numbers. So here we don't have any common members in between two, so this type of sets are called disjoint sets. Power set. The collection or a set of all possible subsets of any set S is called the power set of S. It is denoted by PS or 2 to the power S. So the power set of S is, for example, set A equals 1, 2. Its subsets are 5 empty sets, 1, 2, 1, 2. So power sets of set A are 1, 2, 3, 4. So these are the power sets of set A. So 2 to the power S equals 5, 1, 2 and 1, 2. Now equivalent sets. Equivalent sets. Two sets are said to be an equivalent sets if the cardinal numbers of both the sets are same. For example, in set A we have 1, 3, 5, 7, and in set B we have 2, 4, 6 and 8. To be an equal sets, there should be cardinal number as well as all the member must be same. But here in equivalent, the cardinal number of the sets are same. Here in set A also we have 4 members. Even in set B we have 4 members. So cardinal numbers of both the sets are same. That's why these two sets are equivalent sets. Let's discuss about the operation on sets. Operation on sets. Union of the sets. Two sets are said to be union of the sets if the given members lies either in A or in B or in both. For example, A equals 1, 2, 3, 4, 5, and in B we have 4, 5, 6, 7. So the union of the set A union B equals, union means either the members of A or the members of B or both. That means we should write all the members of set A and B without repeating. So 1, 2, 3, 4, 5, 6 and 7. So this is A union B. Now let's discuss about the intersection. Intersection of the set A and B. Intersection means common members in between the two sets. For example, in set A, let's take the same example. 1, 2, 3, 4, 5 are the members of set A and B equals 4, 5, 6 and 7. Intersection in between two sets means, this is the symbol of intersection. A intersection B is only the common members. So what else are the common members in between two? Let's compare. 1, 2, 3, 4, 5. Here we have 4 and 5 common in both the sets. So A intersection B is 4 and 5. So I like to repeat one more time. Union means common as well as the remaining members either in A or in B or in both. And in intersection, only the common members of set A and B. Now let's talk about the difference. Difference. For example, A difference B. If we have a member in set A, 3, 5, 7, 9, 11, and in set B we have 9, 11, 13. So A difference B means from set A, we have to remove all the members of set B. So pure A difference B means members which are in A but not in B. So we should remove all the members of B from A. So 9 and 11. So 3, 5, 7 are the difference between A and B. Difference of A and B. A difference B. If we need to find out B difference A, so we need to remove all the members of A from B. So 9, 11, 13 we have in B, and in set A we have 3, 5, 7, 9, 11. So B difference A means from B we need to remove the member of A, 9 and 11. So B difference A is 13. So this is how we need to do difference. The complement of set A is all the members of universal set that does not belongs to in set A. For example, if we have 1 to 20 in universal set, okay, 1 to 10 in universal set, and in set A we have 1, 3, 5, 7, 9. Now complement of set A means members which are in universal set but not in set A. Beside 1, 3, 5, 7, what else are left in universal set? 2, 4, 6, 8 and 10 is the complement of set A. So complement of any set means beside that set remaining members of universal set. Symbolically, A complement equals X such that X belongs to U but X does not belongs to A. The example of A complement is, suppose this is an universal set and here is set A. Complement of A means beside set A all the members of universal sets. So beside set A all this shaded region represents A complement. Now symmetric difference. Symmetric difference. The union of the differences A difference B and B difference A of two sets A and B is called symmetric difference. If A and B, we denote it by A delta. This is the symbol of delta and we read as A delta B. A delta B equals A minus B union B minus A. For example, set A equals sun and earth, and in set B equals moon and earth. So A difference B. From A we need to remove the part of B. That means A difference B is sun and B difference A is members which are in B but not in A. That means moon. So A delta B equals A minus B union B minus A. A difference B union B difference A. That means sun union moon. So sun and moon. We can show this even in Venn diagram. So here earth is common in both, so we write earth in the middle, and here sun and here is moon. So this is A, this is set B, this is A difference B and this is B difference A. So A delta B equals A minus B union B minus A. So what we write over here is sun and sun union moon. That means sun and so this is called symmetric difference.